Alright, what's up guys? In this video we're going to pick up some calculus here, and we're back on the topic of improper integrals. So we're going to evaluate this improper integral here from negative infinity to 0. We got 1 over the square root of 3 minus x all integrated with respect to x, or we just simply need to state that this integral is divergent. So basically what you do for the improper integrals is you have to replace the infinity with a variable, and then take the limit of the result. So typically the variable that's used is t, so you replace it with the t, and then evaluate the integral and take the limit of the result. So we've done this before, and basically an improper integral, there's various types of improper integrals, but basically improper integrals when an integral either has infinite limits or it has a discontinuous integrand. And since infinity is not a finite value, you can't just plug that in by using the fundamental theorem of calculus. So you have to replace the infinity with a variable. Again, typically t is going to be used. So, and we've done these before. So the improper integral from negative infinity to 0 for 1 over the square root of 3 minus x integrated with respect to x. This just becomes the limit as t goes to negative infinity, since we have negative infinity here. And then we'll replace our negative infinity with a variable, which will be t. The 0 remains the same. And then we got 1 over the square root of 3 minus x, all integrated with respect to x. So some of these improper integrals can be computed without using any integration techniques at all, but some cannot be, and you need to do a little bit of preliminary work before you can obviously get your answer. So the best thing to do in this case, if you don't know how to integrate 1 over the square root of 3 minus x with respect to x, just evaluate it as an indefinite integral first, and then we'll take the limit of the result. Well, evaluate it from 0 to t, and then take the limit as t goes to negative infinity. So let's just evaluate it as a indefinite integral first and see if we can get our antiderivative, and we'll take it from there. So the best thing to do for this is to do a u substitution, picking u to be, perhaps an equal sign there wasn't the best thing to put, but we'll pick u to be 3 minus x. Then that means that du will be negative dx. And so essentially what happens is you'll get the integral of negative 1 over the square root of u, all integrated with respect to u. And remember that the square root of u, that's the same thing as u to the positive 1/2. So if I wanted to move the negative out front and move the u to the 1/2 up top, that would make it negative. So essentially this is the same thing as negative integral u to the negative 1/2, all integrated with respect to u. And so when we integrate this, we'll simply get negative 2u raised to the positive 1/2. And since we know that the square root of u is the same thing as u raised to the positive 1/2, this is approximately equivalent to negative 2 times the square root of u, technically plus c. And we would have to put our u back in there. Remember, u was 3 minus x, so we got to stick that back in. So essentially, if we would evaluate this as an indefinite integral, we could say that the answer for the integral of 1 over 3 minus x, all integrated with respect to x, we could actually say that the answer would just end up being, if this were an indefinite integral, it's not, but let's just think of it that way. It would just be negative 2 times the square root of 3 minus x plus c. But we know it's not indefinite. So now that we've computed the indefinite integral, it's easier to evaluate the improper integral now. So we just have the limit as t goes to negative infinity, and we still got negative 2 times the square root of 3 minus x, except we evaluated this time from t to 0, and then we'll take the limit as t goes to negative infinity. That's kind of how it works. So we know this gives us the limit as t goes to negative infinity. And we apply the fundamental theorem of calculus. So we'll get negative 2 times the square root of 3, because we stick in a 0 for x. And then this would be minus 2 times the square root of 3 minus t. And we'll take the limit as t goes to negative infinity for this. And I guess I'll come down here. So we got the limit as t goes to negative infinity for negative 2 times the square root of 3 minus 2 times the square root of 3 minus t. And what we're going to get for this is just negative 2 times the square root of 3. We take the limit as t goes to negative infinity for 2 times the square root of 3 minus t. That's just going to give us what's actually going to be negative infinity, but we'll have two negative signs, thus making it positive. So this will be plus infinity. And obviously this just is going to give us infinity. And so since our the value after we take the limit as t goes to negative infinity is positive infinity, which is infinite, that means that this is a divergent improper integral. So without having to go to another sheet, I'm just going to write our final answer up on top. So the final answer for this improper integral is that this improper integral is divergent because we end up getting infinity when we evaluate it. And that's how you tackle the improper integral. So the best thing to do, as I mentioned, is to probably evaluate the if you need to use any specific type of integration technique. Sorry, it's a little bizarre the way I'm doing my answer. Normally I write it at the bottom, but I don't want to go to another sheet and waste any paper. But typically what you want to do for these improper integrals, and some of them can be easily, now if you know the antiderivative right off the top of your head, then that makes it even easier. Then you can just go ahead and evaluate and then take the limit as t goes to whether it be negative infinity, positive infinity, whatever it is. But you typically want to try to evaluate the indefinite integral first if you need to, and then just evaluate it from t to whatever, or from whatever value to t, and then just take the limit as t goes to whether it be negative infinity or positive infinity. And that's basically how you do it. So sorry for sounding so repetitive, but I kind of want to get my point across on that. So that's the improper integral. So I'm going to post another video showing those. Again, an integral can be improper even if it has finite limits, but it's discontinuous on the interval of integration. It can still be considered improper. Those are a lot harder to spot, but these are going to be improper integrals. All right, so let me know if you got any questions about this, but this is how you do it, and I will see y'all next time.